Hello everyone, welcome back to Internet Mathematics. My name is Victor and today we're going to be learning about similar triangles and scale factors. So last year we looked at congruent triangles which are exactly the same size. Today we're going to look at similar triangles. Similar triangles are the exact same shape but with different sizes. So one is zoomed in as I'm zooming out in right here, or zoomed out version of the other. So as you can see on your left, which is the blue triangle here, here's a small triangle with sides of 3, 4, and 5. And on your right, this is going to be the larger version of it. The angles are going to be very identical. The bottom side, as you can see right here, is going to be 8 right here, and the opposite here is going to be 6. Yep. And the hypotenuse is going to be x. Now, let's visit our habits here. So same shape, different size, and you want to figure the scale factor. So scale factor, I've done it for you guys. You just need what you need to do. Because they are so similar, they are linked with a single multiplier. This is called the scale factor. And the scale factors equals the image divided by the original. The image is the new shape, it's the bigger shape right here. The original is the starting shape. To find the scale factor, we must match the corresponding sides. We need to need a pair of sides where we know both numbers. So we can look at here. We look at the bottom sides. We have 4 on the small one and we have 6 on the large one. They correspond. So I can write the scale factor as the following. So the SF, which is the scale factor, I'm going to rewrite that. I'm going to write 8 over 4 because I'm using the image, which is 8 here, divided by the original, which is 4. And so 8 divided by 4 is 2. The scale factor is 2. This means that on every side on the large triangle is exactly twice as big as the small triangle. Now we can find x, and x is the hypotenuse on the large triangle, as you can see right here. Its corresponding side is the 5 on the small triangle. So basically x equals 5 multiplied by 2 because there's the scale factor of 2, and we'll have 10 centimeters. So to go from small to large, we multiply by the scale factor. So we have x equals to 10 centimeters. So let's go a little bit backwards. What if we have a base triangle, a large triangle, let's see. So large triangle, we have a base of 12 and then 15. So I have to draw this out. So we have something like this, for example. So angle is going to be 40. Okay, so I'll write the angle to be 40. The smaller one, 40 here. And then the here, I'm gonna draw a smaller one for sure. So something like this. It definitely has a scale factor. It's not perfectly half, but again, this is just representation. So as you can see right here, I have a large triangle and I have a small triangle. I'm gonna name this the base as 12, the side is 15, and I want the small triangle to be the base of 4 and the side of 1. Now I want to find y. Now I want to match the corresponding sides so we know both bases, 12 to 4. So I'll write SF, which is the scale factor. I'm going to consider the small one, the original. So the scale factor is only equals 12 over 4, the image over the original, which is going to be 3. So I have the scale factor, which means that the big triangle is 3 times bigger. Now I need y on the small triangle, and the corresponding side is going to be 15 on the big triangle. So to find y, it's very simple. I'm going to zoom out. I'm going to write y equals 15 divided by 3, because if we multiply by 3, then y is going to be bigger than this big triangle. So we must divide by 3 to get smaller. So 15 divided by 3 is 5. So y is going to be 5, and I write 5 here. That's it. Okay, so that should be it. To remind yourself today's habits, always match the corresponding signs to find your ratio, and remember the golden rule is that scale factor equals the image divided by the original. If I can write that for you guys again, I have something like this. So the image is going to be I over the original. Multiply to zoom in, divide to zoom out, and I'll see you in the next video. Thanks for watching.